Welcome to the lesson video on cross-validation. In this video, we're going to talk about cross-validation, which is a robust method for measuring predictive performance. In the past, we've said to measure performance, we want to take a random sample of our data and set that aside as our test data, and a random sample for training data. And we would train our algorithm on the training data, test on the testing data. The challenge with this, or the problem that can come up, is this is dependent a lot on what observations happen to fall into the training and test data. Cross-validation is the process of taking multiple test train splits on a data set and then averaging accuracy across those multiple test train splits. Cross-validation is really the standard or proper measure for measuring predictive performance. So here's how k-fold cross-validation works. So we split our data set into k subsets, and we're going to iteratively use these subsets for training and testing. And so here in the example setup on the screen, we're doing 5-fold cross-validation. So this blue bar represents our data set, and we've cut it into 5 roughly equal-sized subsets. Then we take one of those subsets, in this case subset 5, and we're going to use that for testing, and we're going to train our method on the other 4, and then we'll compute accuracy or error. Then we're going to train on a different subset of 4 and use different subset for training, and then we're going to use subset 4 as our test data. And then the next time we go through, we use subset 3 as our test data and the rest for training, and subset 2 for our test data and the rest for training, and then subset 1 for our test data and the rest for training. And you can see or imagine that the accuracy or error that you compute by averaging these is going to give you a more robust measurement of accuracy or error. This is because every observation has been used in a test data set in one of these iterations in the process. And we tend to use the variable k to denote the number of subsets that we're going to create for our cross-validation. So 10-fold cross-validation would be splitting into 10 subsets. Most often we use k equals 5 or 10. There's some theoretical justification, and there's some empirical just observation and using what works well over time to support the choices of k equals 5 or k equals 10. There's another form of cross-validation that comes up called leave one out cross-validation, or LOOCV for short. And in this cross-validation, we use k equal to the number of observations. So really what we're doing is we set aside one observation for our test data, we train on everything else, and then we test it on that one observation that we set aside. And then we run through this using every observation once as the test data set. It's a good way to do cross-validation, and it's useful particularly when you have a small data set. You have a large data set, this can be too time-consuming and it can be unnecessary. And there are some theoretical reasons why leave one out cross-validation may estimate the error not as well as, say, 10-fold cross-validation. So in review, we've talked about k-fold cross-validation. Good way to remember k-fold cross-validation is just from this diagram right here, showing splitting our data into 5 subsets and then testing on one and training on the other. And of course, we iterate through each of those subsets being the test data set. And we've talked about cross-validation accuracy error is always more robust than a single test train split. And typically, we use k equals 5 or k equals 10. And we talked about leave one out cross-validation, where we train on everything except for one data point, and then we test on that one data point, and we iterate that test data point or test observation through all the data in each of the observations in our data set. This is equivalent to using k equal to the number of data points in the data set.